This is the lesson for 11-3. What you're doing today is looking at quadratic functions. Remember, quadratic function is a U-shaped graph, whether it's a U-shape or an upside down U-shape. And we're going to be looking at characteristics of those graphs. So the first thing that I need to teach you is something called interval notation. It's where you're saying that something is in between this number and this number. The smaller number in interval notation always goes first. Your bigger number always goes second with a comma in between. If it doesn't include the number, it is going to be the roundy parentheses, all right? The parentheses that are above the 9 and the 0 on your keyboard. This is called an open interval. You're going to use roundy parentheses anytime that you have less than or greater than. It doesn't include the number, all right? That's when you're going to use roundy parentheses. If it includes the number, all right, you're going to use these squarey kind of parentheses. Some people call them brackets. On your keyboard, that's by the next to the P on your keyboard. You're only going to use these squarey kind of parentheses or brackets when you have the or equal to's, when you have greater than or equal to or less than or equal to. So if it's just less than or greater than, it's roundy. If you have the or equal to, that's when it's squarey, all right? Sometimes you notice that, take a look at this. Sometimes you'll have one of one and one of the other. It could go the opposite way as well, or they could both be roundy or both be squarey. It all depends on how the problem is written, all right? You're also going to be using the infinity symbol today, right? The infinity symbol sort of looks like an 8 on its side, or some people call it 2 circles right next to each other, all right? But infinity means that it goes on forever. We're going to have graphs today that, you know, that the arrows on the ends of the line means that it goes on forever. Roundy parentheses are always used whenever you use the infinity symbol. That's super, super, super important. They love these questions as multiple choice questions on your Regents exam. You can go anywhere from negative infinity to positive infinity. Negative infinity starts going -1, -2, -3, -4, eventually -5 million, -10 million, -1 billion, right? We keep on getting farther and farther away from 0 on the number line. Infinity starts off at like 1 and goes 1, 2, 3, and then eventually to a million, 5 million, 10 million, a billion, and keeps on getting more and more positive, all right? So, for example, the interval squarey parenthesis A, comma, infinity, means that you would have numbers that are greater than or equal to A. It's starting at A. It includes A. That's why we have the or equal to. But then it's all the numbers that are bigger than it. So it's starting here and going towards infinity. When you take a look at interval notation, we're really looking at what's in between those two things. So what's in between A and infinity, right? It's all those numbers. But we could also, if we were just looking at all the numbers that are greater than A, that's when you would use the roundy parentheses. So that wouldn't include A, all right? We're going to do more examples of those in a second. So converting inequalities into interval notation. You have to know how to do this. They love these questions as multiple choice. So 5 is less than X, which is less than or equal to 10. So we're looking at numbers that are in between 5 and 10, but don't include 5. So it would include like 5.01, 5.02, 5.03, but it does not include 5 exactly. So because it's less than, we would use the roundy parenthesis, 5, and then comma, we're going to have 10 because that's our second thing. And then you have to decide whether it's going to be a roundy or squarey. Because it is or equal to, that we're going to use the squarey parentheses. So that's what it would look like in interval notation. -3 is less than or equal to M, which is less than or equal to 8. Because of the or equal to's, anytime that it's or equal to, it's going to be a squarey parenthesis. So squarey parenthesis -3, 8. Again, it's or equal to, so it's going to be squarey parenthesis again. -10 is less than t, which is less than 8. Notice that there is no or equal to, so we're going to use roundy parenthesis, -10, 8, and then it's not or equal to again, so it's going to be roundy parenthesis again. In these ones, x is greater than or equal to 5. X is greater than or equal to 5. Now think about that. If we want all the numbers that are bigger than or equal to 5, that means we're starting at 5. It includes 5 because of the or equal to. And then we're getting bigger and bigger and bigger and bigger. When do we stop? We don't. So therefore, it keeps on going and going and going until it gets to infinity. It never ends. We want all the numbers that are bigger than 5. Anytime that you use infinity, it's always a roundy parenthesis. That is super, super important. M is less than 4. So we want all the numbers that are less than 4. Does it include 4? No, it doesn't. So it doesn't include 4, so it's going to be a roundy parenthesis at 4. We want all the numbers that are less than it. So we want to go all the way. We're not going to put infinity this time. We're going to put negative infinity, because it would start going 3, 2, 1, 0, -1, -2, -3, -4, and so on and so forth, all the way to negative infinity. N is less than or equal to 6. Because it is or equal to, it's going to be squarey parentheses. We want all the things that are less than it. So we're going to have negative infinity. Again, anytime that you have infinity, it is roundy parentheses. They love those questions as multiple choice questions on your Regents exam. Now, not only will they put it in numerical form questions like this, they'll also have it in word form like this. All real numbers greater than -2, but less than 6. So obviously -2 and 6 are numbers. Smaller number always goes first, bigger number always goes second. Greater than -2. It doesn't say or equal to, so it's roundy parenthesis. Less than 6 doesn't say or equal to, so it's roundy parenthesis. All real numbers greater than or equal to 50. So greater than or equal to 50. So we want all the numbers that are bigger than 50. We're going to start at 50. Notice that it says or equal to. Since it says or equal to, that's going to be squarey parentheses. And we want all the numbers that are bigger than it. So that's going to be all the way through infinity. Anytime that you use infinity, it is roundy parentheses. Think about this one. Try this one on your own. All real numbers greater than or equal to 1 and less than 5. Try this one on your own, please. Obviously, our numbers are 1 and 5. We want all numbers greater than or equal to 1. Therefore, it's going to be squarey parenthesis. Less than 5, roundy parenthesis, because there is no or equal to. All real numbers less than n. Now, this gets a little bit confusing because they don't give you a number. They just give you n. Well, you can sub in your mind any number. It doesn't really matter. If I wanted to say all real numbers less than 4, all right, I want all the numbers that are less than 4. So 4 is going to be the highest that it's going to be, just like n is going to be the highest that it's going to be. It doesn't say or equal to, so it's going to be roundy parenthesis. But we want all the numbers that are less than n or less than 4. So this is going to be the infinity symbol, but it's going to be negative infinity. Now, I wrote a 4 there. Obviously, you would not have a 4 in your answer, all right, because it says n. I was just using 4 as an example. This is where n would be. So negative infinity, comma, n with roundy parentheses. All real numbers greater than or equal to n. Greater than or equal to n. So we want all the numbers, again, just replace it with like the number 4 for your thoughts. We want all the numbers that are bigger than 4. That means 4 has to be the smallest that it is, and it would go all the way up through infinity. Anytime you use infinity, roundy parentheses, or equal to is going to be squarey parentheses. All real numbers greater than n and less than m. So this time they give you 2 letters. So we're going to have n, comma, m, greater than n. That's going to be roundy parentheses because there is no or equal to m. So that means we're going to have squarey parentheses. That is super, super important. Again, they love these type of questions as multiple choice questions. Now, the other part of today's assignment gets a little bit more specific with our graphs. So for this one, we have our equation. Your equation will be given to you. All right. What we're doing in this is we are launching a model rocket. All right. It has an initial velocity of 160 feet per second. So our V sub 0, that just means where we're starting is at 160 feet per second. So at initial blast off, that's how fast it's going. And our H of 0, we're starting at the very beginning at 0 seconds. All right. Describe the independent and dependent quantities. Think all the way back to chapter 1. Remember, independent is always your time. So independent in this case would be time in seconds. They love these questions on your Regents exam also. Independent is always time. The dependent, as our rocket travels, think about our rocket. Here's our ground. If we start our rocket on the ground and it launches, it's going to go up, 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 up. Eventually, it's going to stop and it's going to go down, 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 down. As time is going on, this is what the height of the rocket is doing. It would get higher, 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 and then all of a sudden it gets lower, 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 lower until it hits the ground. So what the dependent is, as time goes on, what's changing with the rocket is the height of the rocket. In this case, we would talk about height in feet. So that would be the dependent quantity. Now, if you actually went and graph this graph, all right, you would type your equation into your y equals. Now, on a lot of the questions, you won't see an X here. You'll actually see a T here in your equation. On your calculator, there is no T button. You're just going to use the normal X button. So I type this into my y equals and I graph it. This is what the graph looks like on your calculator. Now, remember, you might have to do zoom and then fit to see the whole graph. Zoom and then fit, which is choice 0 after you hit zoom. This is what the table looks like. All right. Remember, you can hit second and table. On your homework, you will have to graph this out by hand. So just do second and table to find your coordinates. So what is the height of the rocket at 6 seconds? Well, this is your time along the bottom. At 6 seconds, what is the height? Well, the height at 6 seconds is right here on our graph. Can I tell exactly where that's at looking at the graph? No, I can make an approximation. I'd say if I had to just look at the graph, I'd say maybe 380 or so. All right. But you can always go to your table. Notice at 6 seconds, all right, at 6 seconds, according to our table, it's at 384 feet. All right, 384 feet at 6 seconds, according to our table. After approximately how many seconds is the model rocket at a height of 200? Now, this is a very, very tricky question. Take a look at the flight path of the rocket. It's starting right here at 0 seconds. How do I know that it's starting right there? Can you have negative seconds? No. So that means this is where our rocket is starting. This is where our rocket is finishing, because our rocket is not going to go below ground. All right, it's not going below ground. So it's starting here and going here. Now, if you just had the normal equation, you'd graph the whole thing. But according to our problem situation, our rocket's not going to start below the Earth. All right, it's not going to start underground and launch up and down. All right, so it's just going to go here to here at approximately 200 feet. Now, if I follow the flight path of the rocket, I'm at 0 feet, 100 feet. It's going to reach 200 feet right here. At approximately what time is that? I'd say at approximately 1.5 seconds, it's at 200 feet. But now, be very careful. Keep on following that flight path of the rocket. 300 feet, 400 feet, 300 feet, 200 feet. Our rocket's going down now. So it's at 200 feet here as well. That's approximately 8.5 seconds. And notice it just said to do an approximation. All right. So I'd say at approximately 1.5 seconds and 8.5 seconds, it's at 200 feet. What is the maximum height of the rocket? Where is the rocket the highest? Remember, this is your maximum point. The max is the highest point. Now, you're going to eventually have graphs that are upside down as well, and it'll ask you for the minimum point, all right, the bottom point. Remember that you can, on your calculator, go to second and calc, all right? I'm going to do that right now. So just give me a second to pull up the calculator. So this. All right, so taking a look at our calculator now. All right, we have our equation in there already. If I go to graph, and then I'm going to go to zoom and fit so that I can see the whole thing. There were a couple people that were confused about how to do your max. All right, remember that you can find your max for sure by going to second and calc. Go down to number 4, which is your max. When it asks for left bound, you need to pick a blinking cursor point. All right, here's my blinking cursor. You can see it moving. You need to pick a point on the left-hand side of the max. So I can pick that point. That's good. Then it asks for right bound. I need to move my little cursor dude all the way over to the right-hand side of the max. Doesn't matter how far or how close. I just need to move it over to the right-hand side. So it's past the highest point now. So once it stops moving, because I clicked too many times, I can just hit enter again for the right bound. Notice that it wants it in between there. That's what we want. And then it says guess. We just hit enter again, and it gives you your maximum. So where is it at its maximum? It's at its maximum at 5. That's 5. 4.9999 is 5. 400. So the maximum height here is at 400 feet. Maximum height is 400 feet because that's how tall it is. All right, that's how tall it is. And after how many seconds? When? All right, at when, it's right here. It's at 5. All right, it's at 5. So at 5 seconds, it's at its max height of 400 feet. Now, the next thing that we need to talk about, all right, the next thing that we need to talk about is, we're done with the calculator here. So let me get off of this. Share my screen with this. There we go. So now we need to describe some other things. And this is where a quiz is going to come into play, all right? We have to identify and describe the domain of the function. Remember, way back from chapter 1, Domain means X, range means Y. They go in alphabetical order. Domain means X, range means Y. What is the domain? All right, what is the domain of the function that we graphed? Now, the domain is your X, all right, of the function that we graphed. That's just the whole entire graph, pretending that there's no rocket word problem. It's just the thing that we graphed. So it's looking at this whole entire graph. Notice that we have arrows at the ends of our graph. So it goes from side to side. Domain is your X. So looking at our X axis going side to side, if we continued on and made our graph bigger, it'd go on and on forever in both directions. So the domain of this graph is negative infinity to positive infinity. It includes all your real X values. Now, the domain of the problem situation. The domain of the problem situation is the word problem. That's what they mean by that. So in the word problem, can we have negative seconds? No. So that means we're starting right here on our X. We're ending right here on our X at 10 because our rocket is not going to go underground. It's going to start on the ground. It's going to go up in the air and land on the ground. So the domain of the problem situation, it is starting at 0 time. All right, it's starting at 0 time and ending when it hits the ground at exactly 10. So it includes that 0, it includes the 10. That's why we have squarey parentheses there. Identify and describe the range. Now, the range is your Y. So we're talking about going up and down. All right, we're talking about going up and down now. The range of the function. So ignore the word problem situation. Just ignore that and just look at the range. Look at the range of the graph. The highest our graph goes is right here at 400. The lowest our graph goes, it keeps on going, right? Because we have these arrows at the end. So our range of our graph is negative infinity all the way up to a max of 400. It includes that 400 because it reaches 400 because that was our max. Now, the range of the problem situation, it's starting on the ground. So it includes 0 and goes all the way up to 400. It includes 0, goes all the way up to 400 and includes that 400. You're going to have questions just like these. The next one, determine the x-intercepts, or they also call these zeros. These 0, they have these questions on the Regents exam every single year. They will give you a graph and ask you, what are the zeros of the function? Zeros mean x-intercepts. Super, super important vocabulary word there. Zeros mean x-intercepts. Where does your graph cross the x-axis? Where does your graph cross the x-axis? Well, I can see that my graph crosses the x-axis right here, and it crosses it right here. So it crosses it at the point 0, 0, and it crosses it at the point 10, 0. Now, these are using roundy parentheses because those are coordinates. All right, those are coordinates. Those are points. All right, we're not talking about including 0 and including 10. These are coordinates. This is where the rocket launched. All right, that's where it launched from, and this is where it landed. Now, your calculator. All right, I have to stop sharing my screen again and do this calculator thing again. The calculator will show, all right, the zeros. It will calculate the zeros for you as well. Second, calc. Notice number 2 says 0. So, oops, I did the wrong one. Second, calc, go down to number 2, which is 0. All right. Notice that it's asking again left bound because there's two answers here. All right, so I need to move my cursor all the way over to the left-hand side of that first 0. All right, this takes a little bit to get there. Keep on moving, keep on moving, keep on moving. All right, my cursor now is on the left-hand side of where I think a 0 is. So I'm going to hit enter. Now it asks for a right bound. I'm going to move my cursor over to the right of it. So that's good. Hit enter. Just hit enter again for guess. And notice that it gave you a 0. The first 0 is 0, 0, which is what we thought. It crossed right here. I lost my calculator. The second 0. The way to find your second 0, hit second calc again, and then 2, which is 0. It asks you for the left bound. So now I'm going all the way over to that other point. I'm going all the way over to that other point, but I want to stay on the left-hand side of it. So that's on the left-hand side. I need to go all the way over to the right-hand side of it. So I need to keep on clicking, 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 clicking to get to the right-hand side of it. That's why they do this left-bound and right-bound stuff, because you can have more than one answer. All right. I'm going to hit enter again. Unfortunately, my graph ends right there, and it looks like my calculator froze, but you would have to, there you go. You'd have to zoom out a little bit. All right, zoom out a little bit to keep on going, going, going. So now I'm on the right-hand side of where I think the 0 is. Hit enter. All right, hit enter. I keep on zooming now. But you have to do a 0 on the one-hand side, left-hand side, a 0 on the right-hand side. And now I'm zoomed out too far. All right, this is bad. So 0 on the left-hand side, a 0 on the right-hand side, hit guess, and notice you have 10, 0 now. All right, 10, 0. So going back to our graph here. So zeros are where it crosses the x-axis, and the calculator can tell you that. Now, the last type of question that you're going to have is talking about where the graph is increasing and where the graph is decreasing. So where is the graph increasing? Our graph is increasing from the time that it's launched all the way up to the max. That's where it's increasing. So it's going from 0 all the way up to 5. Now, this is very important. Roundy parenthesis when you're talking about increasing and decreasing. That point at the top, which is our max, when it reaches the max, it's no longer increasing or decreasing. It's sort of at that max point. It's sort of hovering there right in the air, frozen in time, just for that split second where it's not doing either. It's reached its point, it stops, and then it falls. All right. So that's why we have to use roundy parentheses with increasing. And then decreasing, it's starting at that max point, going down, 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 down until it hits the ground. So it's starting at our max, which is 5, and then going down to second 10. And that is where it stops. It includes that 10. So from this point to this point in the yellow, it's increasing. From this point to this point in the green, it's decreasing. So from second 0 to second 5, it's increasing. From 5 to 10, it is decreasing. But again, at the max, all right, at the max, you have to use roundy parentheses at your max. Same thing would be for the min, all right, at that vertex, that's what it is. How does the absolute maximum or absolute minimum help you determine each interval? That max or min is the turning point, all right? That's where it stops going one direction and starts going the other direction, all right? That's where you're going to use the roundy parentheses. So let's take a look at what your questions are going to look like, all right? Your questions are going to look like this. Identify the following attributes of your function. And this is exactly how your quiz questions are going to look. I think we have time to maybe try 2 of these, all right? So take a look at this one. First of all, where is the vertex? All right, where is the vertex? The vertex is the turning point. So your vertex is right here. All right, that vertex, according to this graph, is over to 1, up to 2. So it would be 1, comma 2. Now we're using roundy parentheses because that's a coordinate. That's a point. Is this point a max or a min? Well, it's the highest point, so therefore it would be the max. Now, the domain. There is no word problem associated with this particular question. So it's not the domain of the problem situation, it's the domain of the whole entire graph. Remember that domain means X, range means Y. The domain of this graph on our X, right, on our X going from side to side, the domain of this graph, notice that it keeps on going and spreading out, spreading out, spreading out. So the domain of this graph would be negative infinity to positive infinity. The range of this graph, the highest this graph goes is 2. The lowest this graph goes is it never stops. So it goes from negative infinity all the way up to 2. It includes 2, so you have to use that squarey parenthesis. Where is the y-intercept? The y-intercept is where the graph crosses the y-axis. Graph crosses the y-axis right there. So it crosses at 0, 0. That is a coordinate, so you use roundy parentheses. The zeros of our graph, where the x-intercepts are. The x-intercepts are here and here in the red. Those are 0, 0 and 2, 0. Again, roundy parentheses because those are coordinates. The interval of increase and decrease. Our graph is increasing, 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 increasing up to that point. So our interval of increase, it starts all the way down at the bottom at negative infinity. Remember, we're not talking about a rocket in this particular question. It's not of the problem situation, it's of the whole graph. So it starts at negative infinity. If we were talking about the rocket, it would start at 0. All the way up to 1. All right. Now be careful. It's 1, not 2. All right. It's 1, not 2, because we're looking at our x-axis. All right. Because we're going from left to right. It's increasing, 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 going from left to right. Remember, increase and decrease always have roundy parentheses. Interval of decrease, starting here and going down. So we're starting at 1 and going to infinity. Because remember, we're going from left to right. Yes, our graph, I'm pointing at the graph. Yes, our graph is going down, but it's as we're going to the right. This is the type of stuff that you're going to have on your homework. If you could please try this one, please. All right, try this one real quick. I'm going to give you about 1 minute. Go ahead and try this one, please. All right, we're quickly running out of time, so I'm going to start. I'm sorry if you didn't get to finish it. The vertex. The vertex is this point right here. It's where the parabola turns. That would be over to negative 2.5. And down, now each one of these is 0.5. I'd estimate that at negative 0.25. That vertex is a min in this case. The x values from side to side, your x values, they go from negative infinity to positive infinity because it includes all of the real numbers. Your range, the bottom part, the lowest is that negative 0.25. All right, so that includes the negative 0.25, and it goes up, 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 keeps on going up to infinity. Remember, always roundy parentheses. The y-intercept, where the line crosses the y-axis, here's where it crosses the y-axis, that is the point 0, 6. Roundy parentheses, because that's a coordinate. What are these zeros? The zeros are your x-intercepts. So it crosses right here, and it crosses right here. So our zeros would be negative 2, 0, and negative 3, 0. Again, those are roundy parentheses because they are coordinates, they're points. Interval of decrease. Interval of decrease goes from here all the way down to negative 2.5. So this would be negative infinity to negative 2.5. The interval of increase, it starts at negative 2.5 and goes to infinity. So your homework questions today look just like these.